While you're watching this video, one of Harvard's most respected scientists is under attack. Not for fraud, not for misconduct, but for asking questions no one else dares to ask. Avi Loeb, theoretical astrophysicist and former chair of Harvard's astronomy department, stands at the center of a scientific storm that exposes something disturbing. Modern science might be more interested in protecting consensus than pursuing truth. And the reason? An object from outside our solar system called 3I/Atlas. Before we dive into this invisible war happening right now in university corridors, subscribe and hit the notification bell, because what comes next will make you question everything you thought you knew about science. On July 1st, 2025, telescopes from the Atlas project detected something unusual crossing our solar system. It wasn't an ordinary asteroid. It didn't follow a normal orbit. It was the third interstellar visitor ever recorded by humanity. Something that came from another star system, crossed the cosmic void for millions of years, and was now passing close to us. Scientists named it 3I Atlas. At first glance, it seemed like just another comet. But as data arrived, something didn't add up. The object was enormous, estimated at about 20 kilometers in diameter at initial detection, much larger than other interstellar visitors. Its trajectory was strange, with a retrograde inclination, almost perfectly aligned with the ecliptic plane, something with only a 0.2% chance of happening by accident. And it was approaching Venus, Mars, and Jupiter at surprisingly close distances. Statistically speaking, this was nearly impossible for a random natural object. That's when Avi Loeb entered the scene. In July 2025, he published a paper with colleagues raising a hypothesis that made the astronomical community explode. What if 3I Atlas wasn't a natural object? What if it was extraterrestrial technology, an alien probe, perhaps even a mothership carrying mini-probes? Loeb pointed out fascinating anomalies. The object didn't show typical comet gases. Spectral analyses revealed something never seen before, an almost pure nickel alloy without iron, exactly like alloys produced industrially here on Earth. The trajectory suggested it might be using the sun for a reverse Oberth maneuver, a technique spacecraft used to brake using a star's gravity. And even more bizarre, the object had an anomalous brightness at the front, not behind, as expected from a comet. As if it were braking, decelerating on purpose. Loeb calculated that if it were a controlled craft, it could intercept Earth by late November 2025. He called this a pedagogical exercise, an exploration of the dark forest hypothesis, the terrifying idea that alien civilizations might preemptively attack any other life they discover before it becomes a threat. But what happened next shocked everyone. The scientific community didn't receive Loeb's ideas with curiosity or healthy debate. It received them with fury. Astrophysicists from institutions like Penn State, the SETI Institute, and European universities published devastating responses. Jason Wright, astronomy professor at Penn State, called Loeb's claims irresponsible and plainly wrong. He accused Loeb of distorting data, cherry-picking evidence, and unnecessarily scaring the public. Wright revealed on his blog that readers were stockpiling long-term food supplies, preparing for an alien apocalypse because of Loeb's speculations. One reader wrote, "I have a bad feeling about this. I want to spend time with my family before the encounter." What was Loeb's response? He didn't reassure anyone. He continued saying we must keep our minds open because the implications are enormous for humanity. He even attributed a 60% probability that 3I Atlas is of alien origin. 60%. For an object everyone is seeing behave like a comet. And this is where things get really strange. Why was the reaction so violent? Why didn't respected scientists simply refute the claims with data and move on? The answer reveals an uncomfortable truth about how modern science works. When the Hubble Space Telescope finally captured detailed images of 3I Atlas, they clearly showed a diffuse coma, the cloud of gas and dust that characterizes comets. For most astronomers, that was sufficient proof. It was a comet. Tom Statler, NASA's chief scientist for small solar system bodies, declared, "It looks like a comet. It does comet things. It behaves like a comet. The evidence overwhelmingly points to a natural body." But Loeb didn't give up. He argued that the lack of detected gas molecules was intriguing. He said the coma could be ice accumulated on a spacecraft's surface during its interstellar journey. He suggested that even asteroids and comets could be rocks terraformed by aliens to disguise their technological nature. He created the Loeb scale, a classification system from 0 to 10, where 0 is definitely natural and 10 is definitely technological. He placed 3I Atlas at level 6, and when data showed no non-gravitational acceleration, which would be expected from a propelled craft, Loeb simply changed the argument. The absence of acceleration is also suspicious because the object is too large for its observed activity. If it accelerates, it might be alien. If it doesn't accelerate, it might also be alien. Do you believe this could be coincidence? Comment below what you think. Is Loeb seeing patterns where none exist, or are his colleagues afraid to consider the impossible? The truth is, this battle isn't new. Loeb had been through this before with Oumuamua, the first interstellar object detected in 2017. At the time, he suggested Oumuamua could be an alien solar sail. The astronomical community violently rejected the idea. They called Loeb a sensationalist. They said he was tarnishing Harvard's reputation. But Loeb didn't back down. He argues that traditional scientists suffer from normalcy bias, a psychological tendency to assume everything follows known patterns, even when evidence suggests otherwise. He compares the resistance to his ideas with the rejection Galileo faced when proposing that Earth orbited the Sun. But his critics have a powerful counterargument. Extraordinary hypotheses require extraordinary evidence, and so far, all the anomalies Loeb points out can be explained by known natural phenomena. The frontal brightness? Comets can have asymmetric comas because of sublimation on the daylight side. The nickel alloy? Spectral analyses can be misleading at a distance. The improbable trajectory? With billions of stars in the galaxy and objects being ejected all the time, rare events happen. A paper from the SETI Institute written by AKM Isanul Haq directly responded to Loeb's claims. Haq demonstrated that 3I Atlas's hyperbolic trajectory, with eccentricity of about 6.1 and velocity of 58 kilometers per second, is totally consistent with gravitational ejection from a distant star system. He showed that alignment with the ecliptic plane, though rare, isn't impossible, because the galactic disk, where most stars are located, is approximately aligned with the solar system's orbital plane. Naturally ejected objects can follow similar trajectories. Furthermore, observations showed no anomalous acceleration, unlike what happened with Oumuamua. And spectral comparison with D-type asteroids and with interstellar comet 2I Borisov shows consistency with natural objects. Spanish astronomers from the University of A Coruña ran simulations and identified 93 possible stellar encounters that could have ejected 3I Atlas, but none showed evidence of artificial interference. For the vast majority of the scientific community, the case is closed. It's a comet. So why does Loeb keep insisting? And why do his colleagues react with such hostility? The answer may lie in the tension between two ways of doing science. On one side, we have the traditional method, conservative hypotheses, exhaustively tested, accepted only when practically all alternatives have been eliminated. It's cautious science that avoids false alarms and protects the profession's credibility. On the other side, we have exploratory science, raising bold possibilities even with limited data, because ignoring a true signal may be more dangerous than investigating 1,000 false alarms. Loeb argues that if there's even a 1% chance 3I Atlas is technological, the implications are so monumental it would be irresponsible not to investigate seriously. His critics argue that giving a platform to unfounded speculations scares the public, diverts resources from legitimate research, and feeds conspiracy theories. Wright accused Loeb of doing irresponsible SciComm by invoking the dark forest hypothesis, the idea that aliens might be coming to exterminate us. He said real people are being harmed, losing sleep, making survival preparations, all because of a theory without solid foundation. But there's another factor at play here. Perhaps it's the most disturbing of all. Prestige, reputation, research funding. In the modern academic world, scientists depend on funding from government agencies, which in turn depend on consistent and predictable results. Making controversial claims can cost your career. It can make you a pariah. It can cause your papers to be rejected, your students unable to get positions, your funding proposals denied. There's a massive institutional incentive to follow consensus, to not rock the boat. And Avi Loeb, with his privileged position at Harvard, his track record of hundreds of publications, his financial stability, can afford to challenge this system. But what about young scientists? What about postdocs fighting for a permanent position? Can they risk being associated with fringe ideas? The incentive structure of modern science may be inadvertently suppressing legitimate investigations, not through conspiracy or bad faith, but simply because the system punishes those who deviate from the norm. If it were an intelligent signal being ignored due to institutional prejudice, how would you react? It's worth mentioning that Loeb isn't some charlatan. He's published over 1,000 peer-reviewed scientific papers. He was Harvard's youngest tenured professor. He directed the Institute for Theory and Computation at the Harvard-Smithsonian Center for Astrophysics. He advised billion-dollar projects. He knows how science works. And precisely because of this, his critics get even more frustrated. For them, someone with that credibility should know better than to make sensational claims without solid evidence. It's like if Einstein, late in life, started saying ghosts are real. His authority would make the statement more dangerous, not less. But for Loeb's defenders, that's exactly the point. You need someone with established credibility to challenge scientific taboos. No one else has enough social capital to survive the controversy. There's also an important historical parallel here. Science has always struggled with paradigm shifts. When continental drift was proposed, the geological community ridiculed the idea for decades. When prions were suggested as infectious agents without DNA or RNA, biochemists categorically rejected it until evidence became irrefutable. When exoplanets were first detected, experienced astronomers doubted the data. History is full of examples where scientific consensus was wrong and dissenters were right. But it's also full of opposite examples. Countless crazy theories that were directly rejected because they had no basis. Flat Earth, astrology, cold fusion, water memory. The challenge is distinguishing between revolutionary vision and pseudoscience. And that's a challenge with no easy answer. In the specific case of 3I Atlas, the object passed through perihelion, its closest point to the Sun, in late October 2025. It was behind the Sun from Earth's viewpoint, making observations impossible for a few weeks. Loeb suggested this would be the perfect moment for an alien spacecraft to execute maneuvers without being detected. Time passed. November came. December is approaching. No invasion happened. 3I Atlas continues its journey through the solar system, behaving exactly like a comet. It will pass close to Jupiter in March 2026 and then leave the solar system forever. NASA confirmed it poses no threat to Earth. So far, all predictions of the natural hypothesis have been confirmed, and all speculations of the alien hypothesis have failed to materialize. For most scientists, this closes the matter. But for Loeb, it's still not enough. He now speaks of 40% probability, adjusting his numbers as new data arrives. He created the Galileo Project, an initiative to search for extraterrestrial technological artifacts in the solar system and beyond. He raised millions of dollars from private donors. He organized expeditions to recover meteor fragments he believes are of artificial origin. But here's the question no one wants to ask. What if Loeb is right about the method, but wrong about the object? What if he's right that we need to take extraterrestrial hypotheses more seriously, but 3I Atlas really is just a comet? Does his error invalidate the larger discussion? Or does the scientific community's overreaction, the anger, the contempt, the personal accusations, reveal something problematic about how modern science handles unconventional ideas? The debate over 3I Atlas is, at its core, a debate about the limits of science. How far should we take speculations? When does a hypothesis become so unlikely it doesn't deserve consideration? How much evidence is necessary before completely dismissing the possibility of intelligent extraterrestrial life? And who decides this? A committee of experts? Majority consensus? The opinion of scientific celebrities? Or each scientist individually, following their intuition and data analysis? Comment below what you think about this. Are you on Loeb's side, believing science needs to be more open to extraordinary possibilities? Or are you on his critic's side, thinking he's doing a disservice to science by promoting baseless speculations? Maybe the truth is somewhere in the middle. Maybe both sides have valid points. What's certain is this war within the scientific community isn't about data or evidence. It's about philosophy. It's about values. It's about how to balance open-mindedness with healthy skepticism. It's about protecting the public from false alarms versus not missing true signals. And it's about power. Who has authority to define what is legitimate science and what is unacceptable speculation? Leave a like if you love this kind of mystery. One thing few are mentioning in this controversy: the influence of popular culture. Movies, series, science fiction books have conditioned our imagination about how aliens should look and behave. When scientists like Loeb evoke scenarios of motherships and alien invasions, they're consciously or unconsciously activating these cultural archetypes. And this can distort both scientific discussion and public perception. Real aliens, if they exist, probably won't follow Hollywood scripts. They might be so strange, so incomprehensible, we wouldn't recognize them even if we looked directly at them. Astrophysicist Robin Hansen, who popularized the Great Filter concept, suggests advanced civilizations might exist but simply not be interested in visiting or contacting other species. Or perhaps they do so in ways that don't involve physical ships, information transmissions, nanoscale probes, or methods completely beyond our current understanding of physics. The fixation on metallic spacecraft crossing the cosmos might be more a reflection of our own technological limitations than how advanced intelligences would actually operate. What they discovered next changes everything. A crucial point Loeb raises that deserves serious consideration: statistics. We've detected only 3 interstellar objects so far. 3. From a universe with trillions of galaxies, each with billions of stars. Our sample is ridiculously small. Drawing definitive conclusions about what's normal or anomalous for interstellar objects based on 3 examples is like visiting 3 houses in a city and thinking you understand all human architecture. We simply don't know enough. And here, ironically, Loeb and his critics agree. We need more data. The Vera Rubin Observatory, which will begin full operation soon, should detect dozens or even hundreds of interstellar objects per year. We'll finally have a statistically significant sample. We can see if 3I Atlas is truly an outlier or just another example of the natural diversity of interstellar comets. And if we detect an object that clearly doesn't follow natural laws, executing impossible maneuvers, emitting radio signals, changing shape, how will we react? If the scientific community has conditioned itself to automatically reject extraterrestrial hypotheses, we risk missing the true signal when it finally appears. Subscribe to follow the unfolding of this story. Because regardless of who's right in this specific debate, 3I Atlas has already fulfilled an important role. It forced us to confront our assumptions. It forced us to ask, are we asking the right questions? Are we looking at data with open minds? Or are we seeing only what we expect to see? Are we willing to consider extraordinary possibilities when they arise? Or are we so committed to the current paradigm that we'll reject disruptive evidence until it's too late? The war in the scientific community over 3I Atlas isn't a battle between good science and bad science. It's an inherent tension in the scientific process, the tension between necessary conservatism and risky openness. Both are vital. We need cautious scientists who ensure we don't jump to hasty conclusions. And we need bold scientists who question assumptions and explore frontiers. The danger arises when one side completely dominates the other. When conservatism becomes dogma, science stagnates. When radicalism loses anchoring in evidence, science becomes indistinguishable from fantasy. And this is just the beginning. As humanity develops more powerful telescopes, sends probes farther, and detects more objects crossing our solar system, debates like this will become more common, not less. Each new discovery will be a test of our methods, our assumptions, our willingness to face uncomfortable truths. Avi Loeb, whether visionary or misguided, forced this conversation to center stage, whose theories about 3I Atlas are probably wrong. But the questions he raised are important, and the visceral reaction he provoked reveals cracks in the facade of scientific objectivity. It reveals that scientists are human, with egos, fears, prejudices, and institutional interests. And perhaps, just perhaps, recognizing this is the first step toward building more robust science, more honest science, more prepared to face the unknown. Because out there, in the vast spaces between stars, things we don't understand are happening right now. Objects are traveling, signals are being emitted, civilizations might be watching. And when we finally have unequivocal proof we're not alone, the question won't be whether we should have taken the hypothesis seriously earlier. The question will be, why did we take so long to look? The universe is full of unanswered questions, and here we go after all of them.